In this video, we will be graphing linear inequalities. A linear inequality is an inequality in two variables whose graph is a region of the coordinate plane bounded by a line. This line is the boundary of the graph. The boundary separates the coordinate plane into two half-planes, one of which consists of solutions to the inequality. The steps to graph a linear inequality is to graph a line as you normally would for any linear equation. And then if you have a less than or a greater than symbol without the line underneath, you're going to use a dashed line because the points on the line don't satisfy the equation. And if you have a less than or equal or a greater than or equal symbol, you're going to use a solid line because the points on the line do satisfy the equation. And then you're going to choose a test point on one side of the line. I usually like to use the point 0, 0 because it's easy to plug in, as long as it's not on the line. It can't be a point on the line. And if the point satisfies the inequality, you'll shade that side of the boundary line. If the point does not satisfy the inequality, then you shade the other side of the boundary line. Okay, let's look at some examples. We want to graph each of these inequalities. First, we need to get them in slope-intercept form. So we want them to be in y equals mx plus b form. But instead of an equal sign, you're going to have an inequality. But we want to isolate y like we would in a normal linear equation. So in this first example, to isolate y, I need to subtract x from both sides. That gives me 2y is greater than or equal to negative x plus 6. And now I need to divide both sides by 2. Now remember, if you divide both sides of a linear equation by a negative number, or if you multiply both sides by a negative number, you have to reverse the inequality sign. In this case, we don't need to because I divided both sides by a positive number, so I did not flip my inequality. So I divided both sides by 2 to get y by itself, and I got y is greater than or equal to negative 1/2 x plus 3. Now, since my inequality is greater than or equal, it has the line underneath, I'm going to use a solid line. So I graph this the same way I would graph the equation y equals negative 1/2 x plus 3. So I start with the y-intercept at 3. My slope is negative 1/2, so I go down 1, right 2. Down 1, right 2, down 1, right 2. I can also go up 1, left 2, and that will also give me some points on the line. And I make a straight line that extends from one end of the graph all the way to the other. Make sure it extends all the way. And then I need to figure out which side of the graph satisfies this inequality. So what I do is I test a point. So I'm going to test the point 0, 0 because it's not on the line and it's an easy point to plug in. So if I put 0 in for x back into the original inequality and 0 in for y, I get 0 plus 2 times 0 is greater than or equal to 6. I simplify that and I get 0 is greater than or equal to 6. Now you stop and ask yourself, is that true? Is 0 greater than or equal to 6? I would argue that is not true. 0 is not greater than or equal to 6. This is a false inequality, which means the point 0, 0 did not satisfy that inequality. And that means all the points below the line are not going to satisfy the inequality, and therefore I want to shade above the line. So I'm going to shade the whole region above the line. And I'm using a highlighter because I have one, but if you don't have a highlighter and you're just using a pencil, it's okay to just kind of do like a dashed, something like this. Let's see. To indicate that that's the side of the line that you're going to shade. Okay, let's try the next example. Again, we want to isolate y. Oh, and I think I had changed this to be a -8 on your version. Okay, so to isolate y, I'm going to subtract 2x from both sides. And I get -2y is greater than -2x minus 8. Now I need to get y by itself, so I divide both sides by -2. And alert, I am dividing both sides by a negative. So I need to reverse the inequality. So my greater than symbol is going to reverse and become a less than symbol. So I get y is less than x plus 4. And this time, since I have a less than symbol without the line underneath, my line is going to be a dashed line because the points on the line are not going to satisfy the inequality. So when I graph it, instead of doing a solid line, I need to remember to do a dashed line. So this line has a slope of 1 and a y-intercept of 4. So I start with my y-intercept at 4, and my slope of 1, I go up 1 over 1. And I make some points on the line, and we are going to want to extend all the way to the other side of the graph. And now I need to make that line dashed. So I'm going to make some dashes rather than a solid line. And there's my dashed line. And now again, I'm going to test to see I'm going to test a point to see if it satisfies the inequality. If it does, that's the side I shade. If it doesn't, that's not the side I shade. I'm going to choose the point 0, 0 again because it's not on the line and it's an easy point to plug in. So I put 0 in for x and 0 in for y in the original inequality. And I get 0 is greater than -8. And I ask myself, is that true or false? And this time, that is true. 0 is greater than -8. So this point, 0, 0, does satisfy the inequality, which means that that point is on the side of the line that's in the solution. So I'm going to shade that side of the line this time. I shade below the line. Shading green this time. Okay, and that would be the solution to my inequality. So the part that you shade, all of the points in that region should satisfy the inequality or make it true. And the points in the region that's not shaded do not satisfy the inequality. Now, a shortcut you can use that might help is as long as you have your inequality, this should say inequality, in y equals mx plus b form, where y is on the left and the mx plus b is on the right, you can use these rules. If you have a greater than symbol, or a greater than or equal symbol, you're going to shade above the line. So if we look back to example 1a, we had y is greater than or equal to -1/2 x plus 3, and we shaded above the line. We shaded in the up direction, not down. And if you have a less than symbol or less than or equal to, like we did in the final inequality in part B, we ended up with y is less than x plus 4, then you're going to shade down below the line. But again, you can only use that shortcut if you have y on the left and the mx plus b part on the right. In this next example, we have an inequality shown, and we are going to write the equation, or actually the inequality that is graphed. So if we find the slope of this line, I'm going to use the 2 points that are sort of highlighted for us. I'm getting a rise and run of both 5. 1, 2, 3, 4, 5. Yep. So we've got a run of 5, and our rise would, I guess, be -5 because we're going to the right and down. So my slope is rise over run, which is -5 over 5, or -1. My y-intercept is going to be the point 0, 1, so b is 1. And so my inequality, well, the equation of the line is going to be y equals -1x plus 1, or y equals -x plus 1. But I want to instead write an inequality. So instead of an equal sign, the inequality is going to be, I'm going to keep the y on the left side, and it's shaded down below. So I'm going to use a less than symbol. And since the line is dotted, a dashed line, I'm not going to put the or equals line. It's just going to be a less than symbol. So y is less than -x plus 1 is our final inequality. And one last example is a word problem. You have a calling card. Calls made using the card within the United States cost 10 cents per minute, while calls made from the US to France cost 25 cents per minute. Write an inequality that relates the number of minutes you can use for calls within the US and the number of minutes y you can use for calls from the US to France. So in this problem, x is the number of calls within the US, y is the number of calls from the US to France. Now, I know calling cards are kind of old school because that's not something you guys use these days, but the money on the card is how much you have to spend. It's kind of like a gift card. Okay, so if we're spending 10 cents per call within the US, it's going to be 0.10 times the number of calls you make within the US. And then 25 cents a call to France, so 25 cents times y, the number of calls you make to France. And we need that to be less than or equal to $25. So that would be our inequality. And now we want to graph it. I'm going to recopy it. To make this easier to graph, I think I'm going to multiply both sides by 10 to get rid of my decimals. I mean, not 10, 100. That will get rid of my decimals. So I end up with moving the decimal 2 places, 10x plus, move the decimal 2 places here, 25y is less than or equal to 2,500. Since this is in standard form, I'm going to use the intercept method to graph this and find my x and y intercept. So my x-intercept is going to be when y equals 0. And so if I plug, if I think of this as the equation of the line, I'm going to take 0 and plug it in for y and get 10x plus 25 times 0 equals 2,500. This term goes away. We get 10x equals 2,500. Divide both sides by 10, and x equals 250. So the x-intercept is 250, 0. Now the y-intercept is when x equals 0. So if I plug in 0 for x, 10 times 0 plus 25y is less than, or, well, I want to just do equals because I'm finding the intercept, the point on the line where it touches the y-axis. That part goes away. 25y equals 2,500. Divide both sides by 25. And we get y equals 100. So the point 0, 100 would be the y-intercept. So I'm going to graph this line by plotting the intercepts. Now this graph only makes sense for y values and x values that are positive. You can't have a negative number of calls. So I'm only going to graph the first quadrant where x and y are both positive. So I'm going to start at 0 on the x-axis, and I need to get up to at least 250. So maybe I'll go 50, 100, 150, 200, 250. Okay, that worked. Now on the y-intercept, we want to get up to 100, so I think I will start at 0 and count by 25s and skip some. Oops, that should be 50. And then 75, 100. Okay, and then I'm going to plot these points. Well, and I should also label my variables. The x-intercept is the number of calls within the US. The y-intercept is the number of calls to France. And I'm going to plot my points. So my x-intercept was 0, 250. My y-intercept was 0, sorry, I said that wrong, 250, 0. And then the y-intercept is 0, 100. And then I connect them. Since my inequality does have the line underneath it, less than or equal, I'm going to do a solid line. And since it's less than or equal, I'm going to shade below. So we end up with this part of the graph shaded. Also, since I want the number, like the amount I spend to be less than $25, it makes sense to shade below the line where you have less calls. So if you have a number of calls that's not in that shaded region, then that would not be within the amount of money that you could spend.